Hello everyone. I hope you all are okay, and I really hope, guys, that the videos we keep uploading are helping you out. I'm doing question 3 from the grade 11 question paper, which was written in the year 2023 in the province of Eastern Cape. This video will just mainly focus on analytical geometry. Please, guys, if you are new to the channel, don't forget to subscribe, and if you haven't subscribed, please do subscribe. And I really hope that preparations towards your final exams are very productive. Okay, let's continue, guys. I'm told that collinear points lie on the same straight line. Okay, that's a fact. If A, B, and C are collinear, then calculate the value of x. I'm already told that collinear points lie on the same straight line, which simply means that they lie on a line which has one gradient, and the gradient of that line doesn't change. Are we together? Hence they are collinear points rather. So for me to deal with this question, just to illustrate, let's say I'll have points A, B there, and C. These 3 points are collinear, which simply means that the gradient of AB is the same as that of BC, and also the same as that of AC. Are we together? So in this case, I can just use 2 gradients, equate them, then solve x. It's as simple as that. Okay, what can I do? I can simplify the gradient of point AB. Simply y2 minus y1 over x2 minus x1, right? I can simply take the y value at point A, which is 0, minus the y value at point B, which is negative 8. This thing is all over the x value at point A, negative 8, minus the x value at point B, negative 5, right? So this will give me a positive 8 all over negative 8. This is all over negative 8. I have a negative x there and a positive 5. It's a negative 5 inside the brackets. When I remove the brackets, I'll have a positive 5, right? So this will give me 8 all over negative x minus 3. This is my gradient of AB. And then the gradient of AC, I can simply say y2 minus y1 over x2 minus x1, right? Okay, I'll take the y value at point A, which is 0, minus the y value at point C, which is negative 14, all over the x value at point A minus the x value at point C, minus the x value at point C, right? So I'll have 14 all over negative 8 minus x. This is my gradient. So since these 2 points, since point A, B, and C, guys, are collinear, I can therefore conclude that the gradient of AB is the same as that of AC. Then I'll solve for x. I'll have 8 all over minus x minus 3 is equal to 14 all over negative 8 minus x. I'm supposed to solve x here. All I need to do is to cross multiply, right? I'll have 8 and then I'll have 14 on the other side. I'll have negative 8 minus x on this side and negative x minus 3 on the other side. So this will give me a negative 64 and a negative 8, which is equal to a negative 14x and a negative 42. Negative 42, right? So now I need to solve for x. Whenever I do that, whenever I bring the 14 to the other side, it will be positive 14x. Are you together? When I take the 64 to the other side, it will be a positive 64. And then all I'll do, all I'm doing, guys, I'm just isolating the value of x, né? So I have 14 minus 8. 14 minus 8, I believe it will give me 6x. And then 64 this will give me 22. And then x will be 22 over 6, which is 11 over 3. So x is equal to 11 over 3. X is 11 over 3. Okay, now let's move to question 3.2. Okay, question 3.2. I'm told that A, B, C, and D are vertices of a triangle. Points D, E are the x-intercept of the straight line AC and AB respectively. Okay, study the diagram below and answer the questions that follow. Calculate the coordinates of M, the midpoint of line BC. The midpoint of line BC, it will be somewhere there, né? That's M. For us to find M, there is a formula there in the back of our question paper. It's x1 and x2, y1 and y2. So this thing is just x value at B plus the x value at C all over 2, and then the y value at B plus the y value at C all over 2. Then the coordinates of M are 3 and negative 4. Okay, let me write them here because I might remove the 3 and negative 4. Okay, calculate the length of AC. Leave your answer in simplified set form. I know that AC, I'll get it by using the distance formula. x2 minus x1 all squared, y2 minus y1 all squared. I'll simply take the x value at A, which is 2, minus the 1 at C, that's 0 squared. Y value at A is 10, minus the y value at C, negative 6 squared na corner. And then I'll have 2 squared, which will give me 4, plus 16 squared. What is the square root of 16? Is it 256? Okay. Yeah, it's 2 0.56. So this thing will give me 260. Okay, 260. I can simply say, guys, the square root of 260 and leave my answer in simplified set form. This will be just 2 square root of 65. This is your answer, né? So the length of AC is 2 times the square root of 65. Now I'm supposed to write down the coordinates of F if A, B, C, F is a parallelogram. If A, B, C, F is a palm. Okay, let's work. If A, B, C, that means F is somewhere here. Are we together? Such that I'll have a line like this and this. And I'll have a situation like that, né? So if point F here have coordinates of maybe A and B, if this thing is a parallelogram, which simply means that the properties of a parallelogram, number one, yes, opposite sides are parallel and equal, but this question is 3 marks, guys. We must not use something which will take a lot of time, né? I know that the diagonals of a parallelogram, they bisect one another. So if I can find the midpoint there, let me call it point T. If I can find the coordinates of T using AC, I can therefore go and find the coordinates of F. How can I do that? The coordinates of T is our midpoint, right? So I'll simply take x1 plus x2 all over 2, y1 plus y2 all over 2, right? So this is 2 plus 0 over 2. I'm using points A and C, right? And then 10 minus 6 all over 2. Therefore, the coordinates of T are 1, positive 1, and 2. So the coordinates of T are just 1 and 2. Excuse me. That's the point where the diagonals intersect one another. So I can simply find the coordinates of F. How can I do so? I know that the x value at F plus the x value at B all over 2 will always give me the x value at T. Same applies with the y. Let me write y in green. Y value at F plus y value at B all over 2 will always give me y value at the midpoint. So now all I need to do is to just simplify. I don't know the x value at F. Okay, I call it A. So I'll simply substitute A there. A plus 6 all over 2 is equal to 1. Right? So that means I'll just cross multiply. I'll have A plus 6 is 2. Then A is a negative 4, right? And then for Y, I did say that the Y value at F is B, and then the Y value at B is a negative 2 all over 2. This will give me 2. When I cross multiply, I'll have B minus 2 is equal to 4. Then B is equal to a positive 6. All right, together. And it makes sense that my x value is negative and my y value is positive. My x is negative because this thing will be at the left, on the left hand side of the y-intercept, and my y is positive because this coordinate is above the x-axis. So I will have a negative 4 and a 6 there. It seems like I've written b again. Yeah, that's better. So the coordinates of f are that negative 4 and 6. Now I'm supposed to show that I'm supposed to show that ABCF is not a rectangle. How can I do that? Okay, for a rectangle, I know that my diagonals has to be equal. Are you together? If my diagonals are not equal in length, then I can conclude that my four-sided shape or my parallelogram is not a rectangle. Are you together? There are many ways to do it, but the number of, how many marks is that one? 3. 1, 2, 3, 4. 1, 2, 3. 3 marks. Yeah, I'm going to use the shortest one. If I can show that AC is not equal to BF, then I can conclude that this thing is not a rectangle. Are you together? Another way for me to prove, I just need to show that this angle here is not equal to 90. All of these angles are not equal to 90. Are you together? But that will take me a while, I believe. So let me just show that the diagonals are not equal. I think that will be quicker. AC x2 minus x1 all squared right? So for AC, I'll just take the x value at A minus the 1 at C all squared, the y value at A minus the 1 at C all squared, and then I did find the length of AC, right? Yeah, there's no need for me to find AC again. I think I just need to find the length of BF. Well, that's why this thing is 3 marks. The length of BF, I'll simply take the x value at F minus the 1 at B, x value at F minus the 1 at B, plus the y value at F minus the 1 at B. So this would give me 100 plus 64, 164. What is the square root of 164? This is 2 roots 41. Right together. So remember that in 3.2.2 I calculated the length of AC and I found it to be equal to 2 root 65. So now I can see that AC is not equal to BF. So therefore ABCF is not a rectangle. It's not a rectangle, neither it is a square. Okay. now I'm supposed to write down the equation of straight lines AC and AB. Okay, let's do that. The equations of straight lines AC and AB. Let me erase here as well. I don't think I'll need this anymore. For me to find the equation of a line, I need two things. I need a gradient and a point, right? So let me find the equation of AC. Before I find the equation of AC, I need to find the gradient of line AC. Simply say y2 minus y1 over x2 minus x1. This will give me y value at A 10 minus the y value at C negative 6 all over the x value at A 2 minus the x value at C 0. This will be 16 over 2, which will just give me 8. And then for the gradient of B, for the equation of AB rather, I must find the gradient of AB. First, y2 minus y1 over x2 minus x1. The y value at A is 10, the x value, and the y value at B is a negative 2. The x value at A is 2, the x value at B is 6. So this thing will give me 12 all over a negative 4, which will give me a negative 3. So now I have the gradients for both lines. I can simply find the equations then. For line of AB, I don't know why I stopped with the gradient with AC. But I'll simply say y minus y1 is equal to mx minus x1, right? So y minus I'll take the point there. So the y1 and x1 represent a point on the line of AB. I can just take point A because it has positive values 10 and 2, and my gradient is a negative 3. Y minus 10 is equal to negative 3x plus 6. So y is equal to minus 3x plus 16. This is the equation of AC. And then the equation of AB, y minus y1 excuse me guys, this one was the equation of AB. Now I'm finding the equation of AC. I can simply use the same points as well. Point A. The y value is 10, the gradient is positive 8, x is minus 2. So I have y minus 10 is equal to 8x minus 16, y is equal to 8x minus 6. So now I can simply say for AC, the equation is y is equal to 8x minus 6, and then for AB, the equation is equal to y is equal to negative 3x plus 16. And then now I'm told that hence or otherwise calculate the size of angle A. They want me to find the angle in between two straight lines. The angle between two straight lines, I just need to find the angles of inclination for those two straight lines, then subtract them. Always the time, guys. Because you can see angle A is between two straight lines, right? So if angle A is equal to theta, the angle of inclination of line AC will be here, and that will be alpha, and the angle of line AB will be here, and that will be beta. So I know that beta is an exterior angle, which is equal to theta plus alpha. But in my question, they wanted me to find theta, so theta will just be beta minus alpha. You can just see I'm just subtracting two inclinations all together. So all I need to do is to find the angle of inclination. Okay, let me keep these. Alpha will be the inclination of AC, right? So how can I find alpha? I know that since alpha has a positive gradient, which is 8, I can simply say this is 10 inverse of tan 8, right? And then what is alpha? Shift tan 8. This is 82.87 degrees. Right, together. And then for me to find beta, since beta is has a negative gradient, I'll simply say 180 minus inverse of tan 3. Remember that my gradient is negative 3, but whenever I find my inclination, I do not substitute negative 3, right? The negative part of the gradient is being dealt for with the 180 minus. So I have 180 minus the shift of tan 3. This will give me 108.43 degrees. Right, together. And then for me to find angle A there, I just need to subtract the two inclinations. So theta will be just 108.43 minus 82.87 degrees. And then this will give us 108.43 minus 82.87, 25.56 degrees. So now I know that my theta, which is angle A, is equal to 25.56. Angle A, 25.56 degrees. Now I'm supposed to calculate the area of triangle ADE. Area of triangle ADE. Area of triangle ADE, I now know that I have 25.56 degrees, right? And I did calculate the length of this guy to be equal to 2 square root of 65. All I need to find is the length of line AB, and then use the area rule to find the area of that triangle, right? So all I need to say is to find AB. X2 minus x1 all squared, y2 minus y1 all squared, right? So I'll simply say 10 minus 6 all squared plus, why am I saying 10 minus 6? Because it's the x value at A minus the x value at B all squared, the y value at a minus the one at b all squared. So I'll simply have 2 minus 6 is negative 4 all squared is 16 plus 10 minus a negative 2 is 12. 12 squared is 144. So 144 plus 16 this is 4 root 10. Aibo. This is 4 root 10, right? So for me to find the area, I'll simply say area of triangle ADE is equal to 1 over 2 multiplied by, they said ADE. Oh wow, ask you seen, guys. I mean, I wanted to find the area of triangle ABC. Okay, but it's the same logic, ne? All I need to do is to find the length of AD and the length of, nah, I don't have to. There are many ways of finding this area. I can use the area rule, or I can simply take the half base times height. For me to use the height, that height has to be perpendicular to my base, right? So since I'm concerned with this triangle here, my height will be this one, the vertical height from this point to this point. And I know that the vertical height is just 10 units. I just need to find my base now. D is the x-intercept of line AC, E is the x-intercept of line AB. Ne? So how can I find my x-intercepts? Let me deal with AC first. The equation of AC is equal to, the equation of AC, I know that y is equal to 8x minus 6, right? For me to find the x-intercept, I know that y is always 0 in the x-axis. I just want to know what is the corresponding x value. So I'll have 6 is equal to 8x, then x will be 6 over 8, which is 3 over 4. So the coordinates of C are 3 over 4 and 0. Okay, now let me find the coordinates of B, of E rather. Use the same thing. The equation is equal to negative 3x plus 16. For me to find x-intercept, y is always 0 in the x-axis, plus 16, right? So this thing will give me x will be 16 over 3. So the coordinates at E is just 16 over 3 and 0. So for me to find the length of EC, just need to subtract the x values. EC, since this thing are on the same horizontal line, I don't need to worry about y values. I just need to say 16 all over 3 minus 3 all over 4. 16 over 3 minus 3 over 4. I'll get 55 over 12. I'll get 55 over 12, right? Yes. So I'll simply say area of triangle ADE is equal to half the base times height. My base is 55 over 12 and my height is just 10. So I'll simply say 1 over 2 multiplied by 55 over 12 multiplied by 10. What do I get? 22.92 square units squared. So that's how I would have found the area of that triangle over there. I hope, guys, the videos are helpful to you and you are very productive. Thank you for your time, guys.